In this video, we'll be learning how to simplify radicals with numerical radicands. We will be using product rule for radicals to do this. Product rule says that the nth root of a product, a times b, can be rewritten as the nth root of a times the nth root of b, where a and b are non-negative and a is a positive integer. So what we're going to do here is we are going to identify the largest perfect square, cube, fourth, whatever the index is, that is a factor of the radicand. We're going to rewrite the radicand as a product, apply our product rule, and then simplify any perfects that we have. Perfect square under a square root, perfect cube under a cube root, etc. Well, to be able to do this, we need to know what our perfects are. So I've listed here for you perfect squares, perfect cubes, perfect fourths, and perfect fifths. You'll see the perfect fourths and fifths get really big really quickly. So chances are, if you're doing a fourth root or a fifth root, it's going to be no more than 3, because otherwise our number gets so big so fast. I don't think that you need to memorize every single number in this list, but it'd be good to have it on a note card or something like that as you're working through problems for quick reference. You will not be able to use such note card on the midterm or final exam, but it would be good to have it as a study guide. And over time, you'll memorize them just because you've looked at them so many times. Let's get on to some examples. Let's simplify the square root of 12. We want to find the largest perfect square that is a factor of 12. The largest perfect square that's a factor of 12 is 4. 12 can be rewritten as 4 times 3. Now we're ready for product rule, which says that we can break this up into 2 square roots. This is the square root of 4 times the square root of 3. And the square root of 4, well, that's a perfect. It's just 2. This simplifies to be 2 times the square root of 3. Next, we want to simplify the cube root of 162. Well, it's a little bit harder with this example to figure out, oh yeah, 4 times 3 gives me 12. Right? 162 maybe is not a number that we're used to using. So here's a little trick you can do. No matter what the index is, divide the radicand by 2. Because if you think about it, what we're trying to do is list the factors and figure out what the largest perfect square that is a factor. And if we were to list out factors of 162, we'd say 1 times 162. Well, that's not helpful at all because that doesn't change our number. The next smallest number that could be a factor is 2. So no matter what the index is, always divide the radicand by 2. All right, so if we divide 162 by 2, we get 81. So now look at your perfect cube list. 81 would fall right here. It's not on the list. So we want to check every perfect cube from that point smaller to see if it's a factor of 162. And you'll just want to use your calculator for this. So 162 divided by 64, I don't get a whole number. So 64 is not a factor. So now I move to 27. If I take 162 and divide it by 27, I get 6. So that tells me that I want to rewrite 162 as 27 times 6. I recommend you always put the perfect first Here we can apply product rule. This is the cube root of 27 times the cube root of 6. And we know the cube root of 27. That's just 3. This simplifies to be 3 times the cube root of 6. I always like to put the perfect first so that when I simplify that perfect, it's in the right position for my answer, that we want the whole number in front of the radical. Next, we want to simplify the fourth root of 324. I'm going to start by taking 324 and dividing it by 2. That gives me 162. So I'm going to go back to my perfect fourth. 162 falls right here. It's not a perfect fourth, so I'm going to check every perfect smaller than that. So we take 324 and divide it by 81. We get 4. Great. So that means that 81 is the largest perfect fourth that's a factor of 324. So let's rewrite this as the fourth root of 81 times 4. Product rule allows us to break this up into 2. The fourth root of 81 times the fourth root of 4. And then we know the fourth root of 81, that's 3 times the fourth root of 4. Last one, we want to simplify the fifth root of 160. I'm going to start by dividing my Radicand by 2. That gives me 80. So I go to my perfect fifths list. 80 is not a perfect fifth. It falls right here. So I'm going to check all my perfects from that point smaller. Dividing 32 into 160, I get 5. So 32 is the largest perfect fifth. It's a factor of 160. So let's rewrite this as the fifth root of 32 times 5. I know the fifth root of 32. I'm sorry, product rule first. Rewrite this as the fifth root of 32 times the fifth root of 5. And now I know the fifth root of 32. It's just 2. And then we bring down this fifth root of 5. The fifth root of 160 simplifies to 2 times the fifth root of 5.